our last lesson in Algebra 1. Pretty exciting, huh? We're going to be looking at how to make predictions about sets of data using scatter plots, lines of best fit, and curves of best fit. A scatter plot is a graph of points that cannot be connected. You know, all the other graphs that we've done, we've connected the points. We've connected the points in lines. We've connected the points in parabolas. But with a scatter plot, you do not connect the points. We use our calculator to help us with these. And so we're going to enter the information into our graphing calculator. And I'm going to ask you to hold on a sec while I grab a copy of this. Otherwise, I won't be able to see the points. Okay, now I have a copy of the handout so that when I pull up the calculator, I'm able to enter those points I just covered up. We're going to go to Statistics, Edit, Arrow, Clear, Enter. We are going to put the minute study in list 1 and the score on the test in list 2. So minute study, 43, 65, 10, 0, 22, 31, 84, 22, 55, 62. List 2 will go the score on the test. So 72, 92, 48, 40, 70, 84, 93, 56, 78, and 70. It's real important right now that you stop and make sure that you are on the same row with your blank line for list 1 and list 2. If the lists are uneven, this is not going to work. We need to turn on our stat plot. So second y equals 1. Now, my calculator already had it turned on. You might have to arrow to the on and press enter. The scatter plot is this first one under type. Press enter. It should pick up that you have data in list 1 and list 2. You can pick the type of mark you're going to use. I like the plus signs myself. And then we're going to press graph. Uh-oh, can't see anything. So zoom stat, and there we go. Our beautiful plus marks representing every point in this scatter plot. The relationship of this scatter plot. Now, I'm looking over here at my screenshot of it, and it's definitely going up to the right. Does it look like it's kind of going up in a line or a curve? And I would say that it's more like a line. In this case, I would say trending up. I'll say upwards, most likely a line. When you trend up, it's a positive correlation. If you trend down, it's a negative correlation. And if there's no trend at all, there is no correlation. So even without a perfect pattern, we can approximate the pattern using either a line or curve up to best fit. The line of best fit and the curve of best fit now on your calculator, well, we'll see this in just a minute. The scores on this civics test appear to be a line. The line of best fit or curve of best fit describes the relationship between two variables and can be used to make predictions about the data. So for example, I could predict, well, if you studied 90 minutes, what kind of test score would you expect to get? If you only studied for 30 minutes, what kind of test score would you expect to get? So for the line of best fit, we've already got our information in L1 and L2. So we're going to find linear regression. We're going to go back to stat. We're going to arrow over to calc. And we want number 4, linear regression. Yes, take my data out of list 1 and list 2. Store regression equation. Calculate. Alrighty. In this case, y equals ax plus b is the way it shows up on your calculator. Okay, and I've got a screenshot of this right here to help us. A on your calculator represents slope, 0.57. B is your y-intercept, 48.03. So the equation, y equals 0.57x plus 48.03. Let's go back, go to y equals, and type this in. 0.57x plus 48.03 graph. Now it's going to draw my graph right through those points, and this is the best fitting line. It doesn't mean it's perfect. It doesn't mean it's exact. We have some points above, some points below, but it's the best approximation of a line through these points. Okay, let's take a look. The relationship between minutes study and the test score can be represented by the function y equals 0.57x plus 48.03, where x is the minutes studied and y is the test score. So, what do you predict for a student who studies 15 minutes? Well, I'm just going to take this 15 and substitute into the equation for x. Y equals 0.57 times my 15 minutes plus 48.03. Let's see. 0.57, I'm using my handheld calculator, times 15 plus 48.03. And that gives us a test score of about 56.58. That seem reasonable to you? Yeah, it seems reasonable to me. If you only put in 15 minutes, you're not going to do very well. Okay, how about 80 minutes? Y equals 0.57 times 80 plus 48.03. 0.57 times 80 plus 48.03, 93.63. Yeah, I think that's good. If you studied almost an hour and a half, getting an A minus, excellent. This one's different. The score is an 84, and that means that's my Y. So 84 equals 0.57x plus 48.03. So I have to solve this equation. I'm going to subtract 48.03 from both sides. 4 minus 48.03, 35.97 equals 0.57x. Divided by 0.57. $63.11. So about 63 minutes. I think that's reasonable. Study for an hour and earn a B on a test. Okay, let's look at curve of best fit. So let's start by creating a new scatter plot. And let's see here. Graphing calculator. I'm going to go to y equals, and I'm going to clear out that line. I'm going to go to stat, edit, arrow up and clear out the data from before. And now I'm going to enter my new data. Hours will be my x. So 0, 3, 6, 9, 12, oops, 15, 18, 21, 24. Okay. 41, 40, 45, 51, 58, 63, 60, 53, 47. Again, make sure that your blank line is on the same row for both lists, otherwise this is not going to work. Graph. Oh, I don't see that very well. Zoom 9, much better for me. Okay, so this has a curve. It goes up and curves down. Definitely not a line. So it needs to be a curve, and it seems to take the shape of a parabola from our the last unit, which was on quadratics. Therefore, our curve of best fit is going to be a quadratic function. So, how do we use our calculator to do this? Well, stat, calc, and I want quadratic regression, which is number 5. Okay, it picked up list 1 and list 2. Calculate. Oh boy. I have different numbers than what we have in the screenshot. Alright, so the first thing I'm going to do is go back to stat and edit, and I'm going to check my numbers. 0, 3, 6, 9, 12, 15, 18, 21, 24. 41, 40, 45, 51, 58, 63. Aha! Right here. That was supposed to be a 47, not a 7. Got to change things for me. So stat, calc, quad regression, calculate. There we go. Now I'm matching my screenshot. Whew. Whenever you get something weird, go back and check your numbers. Chances are you typed them in wrong. So, A is going to be 0.99, ooh, goodness. Let's do 0.10. B is going to be 2.96. And C is going to be 35.58. I'm rounding to two place values. Our equation is going to be y equals negative 0.10x squared plus 2.96x plus 35.58. Now let's put that in our calculator. Y equals negative 0.10x squared plus 2.96x plus 35.58. Graph. pretty nice curve. I go through a lot of those points. I've got a couple that are below, a couple that are above, but we've done a good job describing this. So, the relationship between the hours passed and the temperature can be described as y equals negative 0.10x squared plus 2.96x plus 35.58, where x are the hours passed and y is the temperature. Now that I have the equation, let's predict for 4 a.m. So I'm going to replace x with 4. Make sure you're using parentheses when you substitute. Okay, I'm going to use my handheld calculator here. Negative 0.1 times 4 squared plus 2.96 times 4 plus 35.58. You would expect the temperature to be about 45.82 degrees. Makes sense. What could we predict for 2 p.m.? Now remember, our time is hours after midnight. So 2 p.m. is actually 14 hours after midnight. Let's substitute. Okay, again, I'm using my handheld. Negative 0.1 times 14 squared plus 2.96 times 14 plus 35.58. And it says 57.42 degrees. That seems reasonable too. What temperature can you predict for noon the next day? So if it's 36 hours after midnight and I put in 36, let's see what we get. Negative 0.1 times 36 squared plus 2.96 times 36 plus 35.58. Wow, I get 12.54 degrees. That doesn't make any sense to me. Noon the next day, based on the temperature from the previous day, should be around 58, 60 degrees. So no, this does not make sense. It turns out that our quadratic model will help, but only up until the point that we've gone beyond 24 hours. So once you go from 0 and you come back and end up on the graph. So let me go back here to my calculator. It makes sense from 0, and it'll make sense out to 24 tick marks here. But after that, it's not going to make sense because we're going to go down into the negatives and have really, really tiny numbers. So we have to be careful about what makes sense and what doesn't make sense when we're using our models to predict data. Okay, take a couple minutes and get started on the assignment.